Hello folks, welcome to my channel Java Demystified by SSR. Here comes the question number 25. What is abstract class in Java? Explain. Let's demystify this question. So we have seen abstraction as one of the object-oriented programming principles. And abstraction is the process of exhibiting the essential features by hiding the background details. And abstraction is achieved with the help of abstract classes and interfaces. And here comes abstract class. And with abstract class, we can achieve 0 to 100% of abstraction. That means an abstract class with all concrete methods and the abstraction achieved is 0. An abstract class with all abstract method, the abstraction achieved is 100. So usually the abstract class will have few concrete methods and few abstract methods. So the abstraction level varies actually from 0 to 100%. If it is 0%, it cannot be actually an abstract class, otherwise it has no purpose. So we can actually make that as a normal class. If it is 100%, then we have a separate concept in Java called interfaces. So abstract class will have some abstraction achieved between 0 to 100. Let's understand what is an abstract class. So if a class contains at least one abstract method, then it should be declared as abstract. That means abstract class is a class which contains at least one abstract method. That is the general definition, but we can also make a class as an abstract class even if the class does not have any abstract methods. So let me explain that. I have a class A here, and this class can be made abstract class straight away. This class is now abstract class, even though it doesn't contain any abstract methods. We can do that. Okay, so why we have to make any class as abstract class even though it is not having any abstract method? That means it is having all concrete methods only. That means an abstract class cannot be instantiated. That means we cannot create objects of abstract class. So by making any class as an abstract, we can actually restrict that the objects for this class cannot be created. So that's the only purpose of making a class abstract, okay, without any abstract methods in it. Okay, so let me clear actually two kinds of methods. So one I am saying abstract methods, and the other I am saying the normal methods, which I am calling as concrete methods. So concrete methods are the methods which have definition or implementation. For example, I am writing a method called void sum, and this sum method has some definition in it. Okay, so this is concrete method. This is what we write mostly in Java classes. And there are abstract methods, and abstract methods are the methods which have no body or no implementation. For example, I want to write some method as an abstract. I have to write something like this. Okay, so there is no body and it must be prefixed with the keyword abstract. Abstract void sum. If you see here, after sum, we have a semicolon. So we don't have any implementation, right? No body. So this is actually an abstract method. Why abstract methods? Why we have to write like this? We will understand. Okay, so usually a class will have concrete methods, and of course from now what we are understanding is a class can also have abstract methods. Abstract methods are the methods which have no implementation, no body, no definition. Just they are declared. Just they are declared. So it's just like a functionality. Abstract void sum. This is just like a functionality, but there is no definition for it. So now what I'm saying is, in general, an abstract class is a class which contains at least one abstract method. Okay, that is the general definition. But a class can be made abstract even if there are no abstract methods. That means class is having all concrete methods and still it can be made abstract. So by doing that, what we are achieving is, since abstract class cannot be instantiated, so by making a concrete class an abstract, we can restrict somebody or some other class not to create object of this class. That's the only purpose actually. So now let's understand few more details here. Yeah, so abstract class cannot be instantiated but can be referred. So what does this means actually? Abstract class cannot be instantiated, that is clear, but it can be referred. Okay, so this is my abstract class. This is my abstract class, and let us assume it has abstract methods only. Okay, it has abstract methods and few concrete methods, whatever it may be. We cannot instantiate it. Okay, so object cannot be created, but this abstract class has some implementations here. So how do we get this implementation? Otherwise, how do anybody else actually get these implementations when we are not creating an object of this abstract class? So there comes actually the point here. Okay, so the abstract classes have to be extended by some other class. Okay, an abstract class has to be extended by some other class, then it becomes a subclass, right? So if a class extends an abstract class, then that subclass should provide the body or implementation for all the abstract methods of that superclass or the abstract class. So here there should exist some class A which is actually interested in this abstract class, which will which will extend this class B. So whenever a class extends some other, there exists class B which extends class A, right? Because this is abstract class, right? So class B, new class, extends class A, then all these things actually will be part of this class B, right? So now it is the responsibility of this class B to provide the implementation for all the abstract methods defined here. Okay, so it is the responsibility of the extending class to provide implementation for all the abstract methods. Okay, so that's the point actually. And if that extended class fails to provide implementation for at least one abstract method, then this class also should be declared abstract. So here this class B, if it fails to provide implementation for any of these abstract methods, then it also has to be made abstract. So then what should happen? There exists some class C that should extend this class B, and now it has the responsibility to provide the implementation for all these abstract methods. So like that, these abstract classes have to be defined in Java. Okay, the point here is a class can be made abstract by just keeping a keyword called abstract. So far we have seen normal methods, those are concrete methods, static methods, and now we are actually discussing abstract methods. Okay, so a class contains at least one abstract method, then it must be declared as abstract class. 2 points. Any class can be made abstract by keeping abstract keyword. Second, if a class contains at least one abstract method, then it must be declared as abstract. So now question, what is abstract method? Abstract method is a method which has no body or no implementation, right? And the third point actually is abstract classes cannot be instantiated. We cannot able to create objects for abstract class, and there should exist some class which should extend this abstract class, and now that extending class should provide the implementation for all the abstract methods of this abstract class. And if that particular extending class fails to provide the implementation, then that class also has to be made as abstract. Okay, so why it should be done like that actually? Why a class should be defined with methods which are having no implementations? Okay, so I will tell you one example. So for example, if you go to an ATM, so any ATM system to draw actually money or deposit or transfer money. So if you go and see, we will have the functionalities there on the screen, and we will select our desired functionality by inserting our card or typing our mobile number, right? Yeah. So if you go to any other bank's ATM, so you will also see the same functionalities in the other ATM of other bank. The same fashion, all ATMs will actually share uniform user interface. Okay, so those are just functionalities, right? And the background implementation varies actually from each bank to the other bank, but all banks will have the same functionalities provided. Okay, so that means what? So there is some regulatory body like RBI which actually provides a template or provides the functionalities for the banks to implement. So the regulatory body just says these are the functionalities that have to be implemented. Now it is up to the banks to implement those functionalities. So here my class A is just specifying the functionalities by declaring the methods, right? And while specifying, it can actually provide few implementations as well. So let us assume there are 10 functionalities, maybe one functionality is implemented here, 9 functionalities that banks have to implement. Now some bank actually interested in ATM. So now what it has to do is it has to extend this particular regulatory body like RBI, and now it has a responsibility to provide implementation for all these methods. Okay, because it is extending, any concrete method is there that is directly available, and all abstract methods it has to implement. It is the responsibility. And this particular class can actually override the implementation provided by this parent class as well. Okay, so that's why this abstraction comes into the picture. So there will be one entity which actually gives you the functionalities, the other entity has to implement it. So this relationship is actually called realization, and it happens among the classes and abstract classes and classes and interfaces. So here abstract classes and interfaces will provide the specifications or the functionalities, will specify what actually is required, and the classes will implement it. So classes will extend abstract classes and will implement, and classes will implement interfaces and provide the body for all the abstract methods. Okay, so that's what actually happens in the abstraction. So now this abstract class I will make actually with a few example. Yeah, so let me have this abstract class A has an abstract method. Because I have made it abstract, so let me write one abstract method. Abstract, yeah, abstract is a keyword, so abstract void fun. Okay, so this is function 1. Okay, abstract void function 1. So this is a method name actually, and I have one concrete class, so void fun 2. This method 2, because it is concrete, so some implementation should be there. So we are actually saying system.out.println and something. So let's say this is method. This is, otherwise I can say this is fun2. Okay, this is from fun2. Yeah. So now I have an abstract class. So this class has to be made abstract because I am having at least one abstract method. So now it is mandatory. Okay. So one abstract method and one concrete method. So what is the abstraction that is achieved here? 50%. So there are two methods. One is abstract, another is concrete. So the percentage of abstraction we are achieving is 50%. Okay. So we are done with the class. Right. Now some class wanted to have this particular behavior. Okay, so it can be any class. You can actually make public class. I want to make this as executable. So class B extends A. Now whenever this class B extends A and A is an abstract class, now it is the responsibility of the class B to provide the implementation for this particular method. Okay, so now it must have to provide the implementation. So void fun1. Void fun1, just we are writing the same thing here. Just copy that and we will paste here, and we will say system.out.println, this is from fun1. So this is from method fun1. Okay, yeah, so that's it actually. So this class B can have its own features, its own methods, etc., but I am not writing as of now. And this class B I am actually making as a main class, so I should have the main method. So public static void main and then string array aux. Yeah. So here what I'm doing is I cannot actually create an instance of this class A because abstract classes cannot be instantiated. So now I can instance only B. So let's say B1 equals to a new B1 equals to new B, and actually through B1, yeah, B1 has how many methods? One, this method has been implemented over here, and this by inheritance it was available. So B1 dot fun1, that is possible, and B1 dot fun2. Okay, so now we are done with actually. So there is an abstract class which has one abstract method. Yeah, so there exists other class, that is B, which extends this abstract class. Now it is the responsibility of this class to provide the implementation. So it is providing the implementation. Yeah, so it is providing the implementation, and then in the main method, so we are creating an object of this B because we cannot create an object for class A, and two methods were called. Okay, so let me save this. So when you compile this b.java, you are going to get a.class and b.class as outcome. So let me actually compile this javac b.java, compile successfully, and you will have two .class files. And now when I run this, and what is the output expected is this is from fun1 and this is from fun2. So that's what actually expected. So this is from fun1 and this is from fun2, and this is clear, there was nothing actually issue. So now one point here is an abstract class cannot be instantiated, but it can be referred to its child objects. Okay, so because an abstract class now has become a super class, a super class can refer to its child objects, right? So what we can do is we can actually make this one a b1 equals to new B. The object created is of child, that is class B, but it can be referred by its parent, that is a b1 equal to new B. This is possible. So because parents can refer to their child objects. Okay, so this is possible, and let me compile and show you that. Yeah, so javac b.java compiled successfully, and when you run you will get this is from fun1 and this is from fun2. Okay, so yeah, so abstract classes cannot be instantiated, but they can be referred. Okay, so now one more thing. If this class has some other method, let's assume I have some method void fun3, and actually system.out.println, and this is from fun3. So this fun3 is actually a child specific method, right? So B's own method, actually B's own method, and whereas this fun1 from class A and fun2 are also from class A. Now whenever you create an instance of B which is referred by its parent, okay, now you try to call this b1 dot fun3. Okay, so this fun1 is available in A, this fun2 is available in A, but this fun3 is child specific method. Now we are calling that with b1, and b1 is of type A. So now we are actually expecting a compile time error. Okay, so let me show you that. Java C b.java. Now we can actually see cannot find symbol b1.fun3 method fun3 variable b1 of type A. So whenever the reference is of type A, we can actually call the methods which are available both in parent and child, but not child specific methods, because class A is parent class and it has only two methods, and this fun3 is a child specific method, and you cannot call a child specific method with the parent reference. So this is not possible. So in order to call this, what we have to do, we have to make up an object of type B, otherwise we can actually make bb1. So now if we say bb1, so now in B all the three methods are available and there will be no problem, right? So only thing what has to be remembered is whenever we are calling with parent reference, that problem will come. So now there was no problem, so because the type of the reference is actually B, and when you run you will have actually fun1, fun2, fun3. Okay, so this is the other part. And now I'm saying abstract classes cannot be instantiated, right? Yeah, so let us understand that also. A from A1 equals to new A. So what I'm trying to do is I'm actually trying to instantiate my abstract class A. So is it possible? Let's save this and understand here. Java C b dot Java, and now you see A is abstract, cannot be instantiated. Okay, so abstract classes cannot be instantiated. Okay, so that is one thing, and I would like to show you one more. Yeah, so now what I do is, yeah, I will make this method, as concrete. So this is from fun1, void fun1, void fun2, and the class A having both the methods as concrete, still it can be made abstract. So now here void fun1, what actually doing here, I'm overriding, right? This is because here the implementation is already there, and in child class I am actually writing that, defining that, so I am redefining, so that is overriding. Okay, so fun3 is child specific method and fun2 directly acquired through inheritance. So now let's see, so now what we are doing, so this is not at all possible. So a1 equal to A is not possible because that is abstract class, and this is fine actually. So class B extends A, okay, and it gets fun2 directly, fun1 is overridden, and fun3 is child specific method. It works, there is no problem. But why actually this class has to be made abstract? So the only advantage that we get by making a class with the all concrete methods as abstract is we can restrict somebody else not to create an object of this class. Because it is abstract, we should not able to create object for this class. That is the only advantage of making a class abstract. Even then even then it has all concrete methods. Okay, so that actually covers all the features of abstract class. Okay, so let me actually tell you one more program with many more details. Yeah, so now I have a class called person, abstract class person. Why I'm saying abstract class person is I have an abstract method here, abstract void it. Okay, so this is an abstract method, that's why this class person must be made abstract. Okay, and this class has some members. Yeah, some two instance members, string name int age, and one class variable, that is static string planet equal to earth. So these are the person details, and of course the person has one constructor also. This abstract class has one constructor also. It constructs both the instance members name and age, and it has one getter method, that is get person. It provides the details of name, age, and planet. Okay, so now an abstract class contains data members, instance class members, a constructor, and a concrete method, and also an abstract method. So this is all possible within a class actually. Now, because it is an abstract class, so we cannot actually create an instance of it. So now there exists some class that should extend this class person and provide the implementation for each method. Whenever it is providing the implementation for each method, all these things are available to that, because the class is interested in extending this. Like a bank wants to ATM, so a bank has to provide the implementation for all the functionalities which are provided by the regulatory body. In the same fashion, so a class is interested. There is a class called student which is interested in this class person, because student is also a person. So now by default, by extending this student class will get all these details. This constructor, this instance members, static members, getter method, okay, everything is available to the student, right? So class student extends person. Whenever this is made, so all the members and this method are available, and constructors will not get inherited, but constructors can be referred through super keyword, right? So here what we are doing, class student extends person, and of course this student has, because he's a student, he has his own feature called grade. Actually every student will have some grade, because that is a character. So grade A, grade B, grade C, something like that. And now, yeah, there is a constructor actually in person class, and now the student has grade and also name, age available from person instance member. So whenever constructor is whenever we have to construct the value for grade, name, and age. So public student string name int age, these two are from my person class, and char grade its own actually. So in order to construct name and age, we have name and age, we have actually a person constructor available in my parent class. So we are referring that with super actually. So super is easy to invoke immediate parent class constructor. So we are doing this. So this name and age will get constructed, and this grade we are constructing over here. So constructor is ready, and we are providing the implementation for this abstract method. So here in person eat method actually was there, which is abstract, and we are providing the implementation. The implementation is void eat. So student eats actually what? System.out.println eats fruits. Okay, and there is a get person method which actually prints name, age, and planet. Now here, this is getting overridden in the student class, because this grade also has to be added. So override void get person name, age, grade, and planet. Okay, so when you want to execute this student class, so let's have a main method, make it executable. So person s equal to new student. So here what I'm doing, I'm not creating a person object, but person can refer to it child objects, right? So parent classes can refer to their child objects. So here I can say student s equal to new student, there is no problem. But we can also say person s equal to new student. A student object is going to get created, which is referred by person, and person is a parent type. This is possible, there's no problem. And while creating the object, I am passing name, age, and grade. This name and age are constructed through the constructor which I have written in the person class, and this a will be constructed over here. So when we say s dot eat, the implementation we have provided, eats dot foods will get created, will get printed, and then get person will give me the details of name, age, grade, and planet. Okay, so this is an example of an abstract class with all the things which are possible. So there are instance member, there are class members, there are constructors, there are now concrete methods, and there are abstract methods. When you have everything, so how to actually make up a program? So this student class will do that actually. Okay, constructor was invoked with the super, parent constructor was invoked with super, then implementation for the abstract method is provided here, and overriding the get person because grade is an additional attribute to be printed, and here an object is getting printed and which is referred by parent type, and s dot eat and s dot get person. So here runtime file marks will happen. So we know whenever a overridden method is called with the parent type, runtime file marks will take place. So let me save this and actually run this program. So first let me java c person dot java. Yeah, person class is successfully compiled, and then java c student dot java. Yeah, student class also got successfully executed. Now let's say java student. So the expected outcome is s dot eat eats fruits and get person and all the details which we have provided. So eats fruit has got printed. So the data which we have provided is ABC 19 grade A, and we are also printing the planet. So the planet actually was set to uh, Earth. So we are actually able to see that particular Earth value as well. Okay, so this is how we can actually make use of abstract class and abstract methods in the child classes. Okay, so to sum up, abstract class is a class which usually contains abstract methods. We can actually make a class even though that class doesn't contain any abstract methods. Okay, so we cannot create an object for an abstract class, but abstract classes can refer to their child objects, and there should exist a class that should extend the abstract class, and it is the responsibility of the extending class to provide the implementation for all abstract methods. If it fails to provide the implementation for any of the abstract method, it should also become abstract, and then there should exist some other class which should implement all the abstract methods. So this class actually is implementing the abstract methods of an abstract class. This relationship is actually called realization. Okay, hope you have understood this abstract class concept clearly. So if you understood properly, please like, share and subscribe to my channel. Thanks for watching.